Thomas, and I want to introduce Dr. Alia Sadawi and Thakur Patel to talk about Blockchain 101. And as we talk about this, and as we talk about Dubai, and we're obviously here, I want to just mention to all of us again, part of the thing that makes this an excellent place, and I say this everywhere I go in the world, is that there is a culture of excellence in Dubai, and we're all a part of that right now. So I want to hand that off to the next speakers. Thank you very much.
Good morning, everybody. The minute I saw the list with the name of the UAE at number 4, I knew Mr. Khalifa will not let this go, because he's an AUS alumni. We don't let anything slip out. Okay. Thank you for being here, and I was asked to give a brief presentation about blockchain. My name is Dr. Alia. I'm a researcher and professor at the American University of Sharjah. I graduated from that university with a PhD in blockchain. So basically, we will start by explaining a few concepts, and I would like to invite Thakur from MetaDecrypt to start a few slides. Please go ahead.
Hello, everyone. I hope you have been having... Hello, everyone. I hope you have been having an interesting session. So the summit name is Web3 MetaDecrypt Summit, right? So first, before we Thomas has well explained what the Metaverse is, what Web3 is. So I will not again repeat what it says because I do not want my session to be repetitive. So let's proceed, because I guess we all now we all have an idea of what Web3 is, right? So to understand more, we have to know the transition of the internet from when it was originated to right now. So we have divided it into 3 phases. It's Web 1, Web 2, and Web 3. So Web 1 was the time in which we know that the internet was invented by colleges when they wanted to share information from colleges of different countries, right? So that is when you only get to read something like a research paper or some information of some particular topic on the internet, and that is what Web3 was about. It was a read-only system. Now come to 2004, when the development of e-commerce platform and social media. So what happened over there was, instead the developers, they made a platform which allowed users like us to write on it. So we can also be content creators. The whole content creation platform about YouTube, about Facebook, this is what is defined as Web 2.0. And another thing which highlights Web 2.0 is the advertising revenue. So the whole model of advertising revenue that had an inception in Web 2.0. And now in Web 3, we get to own whatever we write. All the content which we have over there, we get to write on the platforms, and we get an ownership of that. Instead of corporations owning all the data, or all our data, as in Web 2.0, Web 3.0 does a change in that. So Web 3 is decentralized, permissionless, native payments, and trustless. It's decentralized, permissionless, because anybody can enter it. There is no specific entry to it, no matter your financial status or no matter your country location. Native payments is cryptocurrency is the native payment, and you can use that to do financial payments without the trust of any third party like a bank. And finally it's trustless, because the whole of it operates on an application of cryptography. So we really just have to trust cryptography, which is maths. There is no human error involved in it. Well, Metaverse, I've just written a line about it. It's a synchronous live experience. It means that it never ends. It's always live. There is no offline time for it. And it is also attached with a fully functioning economy, because it's a different world. Then there's an economy attached to it. And it's available, and it's made available to everyone using blockchain infrastructure. So now we'll have to understand what blockchain is, right? Because I've written that over there. So what is blockchain? So generally, first, what comes to your mind when you hear the word blockchain? At first, let's say 2 years ago, everybody would have been confused about Bitcoin, cryptocurrency, as what blockchain is. But it's much more than that, and its use cases, as we had seen, as Thomas had explained, it's not only in the financial sector. You can use it in every different sector, and he has shown some interesting examples with values of how it was done and how it was a success. So a bit about the technical part about blockchain. So it's a system that holds transactional records. It's while ensuring security, transparency, and decentralization. What does this mean? By security, you can say that it's immutable, because once you enter something into the ledger, you cannot delete it anymore. You can update it, but there is no deletion over there. So everybody will be well aware of when a data is updated, and everybody who is a part of that blockchain system, every user, every node will be notified of the same. Next, it's trustless. There is no need for a central authority, because it works on applied cryptographic concepts. And it's secure, again, through cryptography, private keys, and other mathematical concepts which the developers do on the back end. And it's transparent. Anybody can view all the info on the network. It's available on BSC, like for Binance, it's BSC scan, Ethereum scan. You can see any data, any transaction between any user. It's available and it's free, unlike the central authorities, in which the data, it's available to only the organization. So before you start a project in blockchain, you have to understand whether you need blockchain. And these are a flow chart which you have to go through, which depends on whether you need a database, whether you need shared write access, whether the writers are trusted and known, and whether you want to trust to a third party. You need control functionality. So it might not be visible because it's at the bottom, but what this finally leads to is in your project, whether you need a public blockchain, whether you need a hybrid blockchain, or whether you need a private blockchain. Dr. Alia will explain more about the differences between these three types of blockchains later in the presentation. So a blockchain works when someone first initiates so it's a network of computers. There are nodes all over. Every computer, whoever's operating on a node, they are connected to each other and they help maintain the authenticity of the network, right? So someone first initiates a transaction. Let's say I'm not a node, but I am just a user who wants to use a decentralized application. So all the things which happen over there is termed in the term of transactions. At first, a transaction is requested. Then the whole mining process goes on. Mining process is different for different blockchains out there. And after that, once everything is fine, the new block is added. This happens only after, everybody comes to a consensus. All the nodes, they come to a consensus. So you're not trusting a central authority, but you're trusting the whole network of people and the economic incentives which they have associated with the whole system. So this is a blockchain structure. You can see that the previous block hash is stored in the next block, and so it's sort of linked. It's like one box linked to the other, so you can always find them. And cryptographic hash functions are something which is what the blockchain runs on. They run on hash functions. When I say I'm going to explain to you the properties of hash functions, and there are 4 different, right? Hiding is when you use a hash function, let's say you get a value y from x, right? So when you see the value y, you cannot find the initial value x from which it was originated. That's why x is hidden. So it's hiding. Deterministic is because there is one value, like no matter how many times you put x through the function, you'll always get y. You won't get z or a or b. It's always x, always gives to y. That's called deterministic. Collision free means no two values, let's say a and b can never give a certain value, like a same value called c. A will give, let's say, d, and b would give, let's say, f, right? And finally, it's puzzle friendly. Puzzle friendly is something which is related to Bitcoin. It's related to mining. So there's a puzzle, and it's solvable given us a certain amount of time. It's not an impossible puzzle, but it's just that it requires time, and that is how the blockchain runs. So hash functions are used as transaction hashes, block hashes, and addresses. An example is like, let's say there are 2 words with a capital S and a small s. So the final output is totally different. That is, let's say, A and B. You can say that you cannot. You're looking at the output, you cannot say that, that the word was same, just there was a different uppercase, lowercase, right? Because this is what a hash function is. When I say that it's deterministic and it's collision free. So Dr. Alia will take the later part of the seminar. Thank you.
Let me take it from here, please. I just wanted to provide a simple definition for blockchain, as you saw in the previous slides, because this technology is very complicated and it has many definitions, depends on how people are perceiving it. So I thought for an 101, just to have a simple definition, and when we go through the complication of the technology, you will figure out that this is more to it. So basically, Thakur here explained one part of the cryptography that makes blockchain unique, secure, and transparent at the same time, which is the hash function. And this hash is the method that is used to link blocks together. But there is a very important concept that makes transactions secure, and that is the digital signature. We all sign documents to authenticate them, and signatures have problems, they get forged. The idea of digital signature and even the idea of smart contract was not new. It was from the 1990s. But how to implement it, how to find the technology that can support the digital signature and the smart contract was the issue. And blockchain came as a rescue. So basically each transaction, and the word transaction, we use it a lot in blockchain, but it's not the same meaning as other people perceive. People think that transactions are only for digital events. So there's a transactions of money, so it's related to a monetary concept. Actually, a transaction in blockchain could contain any type of information. We still call it a transaction. So each transaction has to be signed by the person who issued that in a digital way to make sure that it is not forged. And this is the basic idea of being secured in terms of the blockchain technology. So what we are using in blockchain is something called asymmetric, means not the same way you are coding your signature, you will be decoding it. So every person will have two keys, a private key and a public key. The private key is something you keep for yourself, that's private. And the public is shared by everybody. So let's say it's your house, the address is known to everybody, so that's your public address, your public key. And the real key that you open the door is yours, you keep it with you, that's your private key. So basically people, when they want to send you a transaction, again, remember what I meant by transaction, they use your public address, means your public key. But when you want to receive that transaction, means you enter your house, you use your private key. So this is how it is done. We are using the hash function, which was explained. We hash the data file, and we use our private key to add the digital signature. Now our transaction is signed. To decrypt it, or let's say to read what is inside the transaction, the public key is used, and we get the hash of the original message, and we compare it with the data file hash, which we can hash it separately. And if these hashes are matching, then this transaction is authentic. Okay, so for a network to be a blockchain, because actually looking at the market now, a lot of blockchains are not blockchains. Okay, so they are distorted blockchains, half a blockchain, because simply the audience does not know much, they cannot differentiate. So they think this is a blockchain because somebody says it is. But actually to be a blockchain, a network has to be totally decentralized. A lot of people who claim their blockchains are totally decentralized, they're not. So decentralization is the first key. The timestamp is very important because transactions have to have a time. Because the transactions that takes place first is the valid one. If I owe you a person a time, like an amount of money, and I transfer it twice, this is double spending. The whole problem is back to square one. But blockchain solved it by using the timestamp. Actually, when looking at Satoshi Nakamoto's paper, blockchain was called time chain. And I don't know who called it blockchain. Everybody says I'm the one, but it's not me. Okay, then the cryptographic part, which makes things secure. This is two parts, the hashing and the private key we just explained, and the consensus mechanism, democracy. Means how these nodes that are participating in the network reach a decision. Because remember, we don't have a central authority. And for the consensus mechanism, we will take a look and we will see that there are many types of them. So in blockchain network, nodes collaborate and governed by a software protocol that enables the secure transfer of money, assets, information via the internet without third-party intermediaries. So no lawyers, no brokers, Nothing. And the important thing here is the protocol. The protocol is everything. So this protocol establishes the consensus as we talked about. But the important thing is, I come back to the transaction part. The transaction is not only money. Anything that could be digitally represented could be put inside the transaction. It could be property rights, music, video files, stocks, anything that is digitally represented. And also in blockchain, the information gets verified without the trust of central authority, but based on the consensus algorithm. So the new block, when it is added to the blockchain, each block consists a number of transactions. Okay, this depends on the blockchain itself. Some blockchains have, let's say, changing number of transactions per block, so different block sizes like BSV, for example. Okay, and they use cryptography and verify them through consensus. Who does that job? These are the miners. Okay, and I like the word miners because they are just like those who mine gold. If you are a miner, you become really rich. But that should be at the beginning. Now it's too late. Okay, the most famous consensus algorithm is the proof of work. We have proof of stake, proof of time elapse, different types of consensus algorithm. I'm not sure if you are aware that there is a debate about the types of consensus algorithms. Some blockchains are talking about the environmental issue of proof of work, which I totally disagree with it. It's only a way to promote POS. And these nodes, as I said, are called miners, and they are receiving some economic incentive because they are spending a lot of resources in that. So let's see how blockchain is secure. What happens? Let's imagine Mr. Pink and Mr. Green had an agreement, and this agreement was securely saved on blockchain. What if, sorry, we cannot go back? No backwards? Third button. Okay. Yeah. So this guy, he looks malicious because the way he's wearing his mask. He's trying to change the deal with Mr. Pink. So what happens here? He's going to that block, but a change in that record will change the hash of that transaction, which breaks the chain. And then he will need to recalculate the hash function for all the successive blocks, which is totally impossible, even if he had the resources. And this will cause the whole blockchain to collapse, and he will be identified. That's why we are secure on digital. Blockchain actually has, I don't want to be into philosophy, just not because I have a doctorate in philosophy. But blockchain is famous for one thing, not because it's a technology, because it's changing concepts in our brain. The conscious mind, the programs that we have a lot of programs. We have a program that says we have to trust somebody. Government, authority, lawyer, broker, husband, spouse, whatever. You don't need to trust him. Even if he has malicious intentions, the technology will not allow that person to act upon them. So this is one of the reasons. And the other concept that is changing by blockchain, we always have the idea that malicious people, evil people are rich. They make more money. And if you're a good person, you will live poor and die poor. But God loves you after all. Blockchain changes that. If you are malicious, you will spend a lot of money and you will gain less. Act honestly, you will be richer. Okay, so two subconscious programs are being changed here, and this is why blockchain, in my idea, is changing a lot of things, and that's why I took it as my PhD topic. Okay, blockchain has 3 types, but there are more to it. But I want to emphasize on one thing, that because we have 3 types, everybody has a room. So basically, you have the public blockchain, and the other ones, they are private, but private to a certain level. So basically, if they are implemented within one organization, this means that we do not need a strong consensus algorithm because entities know each other. There is always a trade-off between things. So if you are going into more secure proof of work or more secure consensus algorithm, this means you have to spend a lot of money, and that will reduce the throughput and the scalability of your blockchain. So nothing comes for free. But if we are looking at the market now, we are having a lot of new blockchains that they are overcoming this. They are public, and yet they are having a very strong protocol in terms of efficiency, and the time is less, and also the consumption of power is much less. And I come back again to BSV. I was on Ethereum all my life, and now I'm trying to find other alternatives. I'm really happy to see more blockchains coming into the market with more, let's say, flexibility. So this is the difference between public and private blockchain. In public blockchain, you just download what is called the client on your laptop, and you are free to be a node. But if you are joining a private blockchain, you need a permission, means somebody to sell you or to give you the password for the client, which is the software that you download to be able to join. Okay, so this is the main difference between them. Okay, let's look at the smart contract concept, which make blockchain really, really huge, because this is automation part. This is the logic part. This is when I owe somebody a huge amount of money, I can control that through an algorithm. So basically, it is what it says, a smart contract. The point here is the smart contract was introduced by a researcher in 1996, and it was kept in books. Nobody could implement it until the evolution of blockchain, because simply it's a set of logic rules that's a form of code script which can be embedded into the blockchain. So each time we run the smart contract, the transaction is the output of our interaction. And these are irreversible, secure, and traceable, and that comes with a very reduced cost. The important part here that smart contract is considered in the terms of computer sciences, turning complete means we can code anything in smart contract. So basically the word smart contract is very small. This ability of programming on blockchain is far beyond only being called a smart contract. This is only a glimpse of some company that implemented their own private blockchain, and we should add the Ministry of Commerce next time after they finish their project. So basically we want to show that all major players in the economy are joining blockchain. To take some summary and notes with us, blockchain is one of the hottest and more intriguing technology in the economic world today. Some considered it at the beginning as a hype. Others call it a tsunami, a revolutionary, like fire. It's resembling the rise of the internet, and basically it was known as the backbone of Bitcoin, but it is far beyond being the infrastructure of a cryptocurrency. Please note, DeFi is a single and simple use case of blockchain technology. Single and simple, okay? So blockchain is challenging established business models and creates new value to be added. And again, it takes trust from the hands of third parties and puts them in the hands of stakeholders themselves. So trust is in your hand. You are not trusting somebody and giving him power over you. During the Cold War, President Reagan made a Russian proverb famous when he said, "Trust but verify." The core innovation of blockchain lies in its ability to verify and validate transactions publicly, securely, privately, immutably, in a time manner, and without being in need of any intermediaries. I think we have some time for Q&A. I'm not sure about the no time. Yeah, but Q&A. Dr. Marwan? Yeah, proof of time ellipse. Yeah, so basically it's only after some certain time, a block should be added by the person that, or the miner that has the transactions in hand. So basically there are more than one type of consensus. But as everybody knows, the first two are the most famous one. But you are welcome to add.
This has to be the last question, I'm sorry. It has to be
I'm
the last.
taking questions.
And it has to be the last question, I'm sorry. Just take one more question.
One more? Okay.
Yeah.
One more.
You mentioned that you disagree with bad influence of mining, and I know your opinion.
Bad influence?
Yeah.
Proof of work. Okay. This is a PhD by itself. This question is a PhD by itself. Everybody is talking about the environment. Suddenly everybody loves the environment. First, I want to say one thing. If blockchain appeared in 2008 and Bitcoin started with proof of stake, do you think it will be successful? Gain trust and momentum? No. Proof of work was the backbone because it is 100% fair. Now, when people are comparing proof of work, they are comparing it to zero. Yani if I owe Mr. Khalifa 5 Bitcoins, or how much it is now, yani $100,000 for example. So if I pay you, either I pay you in using blockchain or I owe you nothing. Yani I will not pay you through a bank transfer or I will not pay you through any other system. So this is what they are saying, that proof of work is compared to zero. But actually, if you are not using your blockchain to transfer your transactions, you are using an alternative system, which is the banking system. Anybody has any record of the carbon prints of the banking system? Can you follow that up? Believe me, it consumes more power. Anybody knows about the cloud servers? طيب, Burj Khalifa, where is Richa? Burj Khalifa is run by huge servers. Do you know how much energy they consume? Diwa people, where are you? Anybody has an accurate carbon footprint record about all these cloud servers? We have Azure, we have Microsoft, we have Google, and they are saying they are offsetting their emissions. In the beginning, how much their emissions are? And who are they to announce them? Who is following after them to check after them? How much these emissions are? We don't know. They are taking our virtues against us. Because we are transparent blockchainers, they can see how much we emit. But they are hiding how much they emit. So this is what's going on. The buzz now is they are comparing proof of work to zero. No, compare a transaction done using proof of work to a transaction done using an alternative system. And then come up with an answer, and I'm sure the answer will be that proof of work is consuming much less. I hope I can defend another PhD now.
Thank you very much. Thanks.